This time, we are tasked to solve for the integral of the given function e to the power of z along the horizontal line segment path from 1 plus 2i to 4 plus 2i. It's very important for us to identify the correct path so that when we use the parameterization, we can use the correct formula as well. Now take note, as mentioned, our given function f of z dz along the path c is equivalent to the integral of your f of z of t times your z prime of t dt from a to b. The item that we would like to identify here is z of t, which will allow us to solve for its first derivative and of course give the actual form of that in using the given function. The z of t is actually the parameterization of the horizontal line segment. In one of the videos previously, we were able to identify that the parameterization of a horizontal line segment works like this. We have our z of t is identified as t plus I k, where your t is between a and b. Yes, this is its form. Okay, because for the horizontal line segment, it's parallel to the x-axis. So the intersection, which is constant for all, is actually your y value in together with the imaginary unit I. Okay, so using your z sub 1 being 1 plus 2i and z sub 2 being 4 plus 2i, we would know the value of our k here because you can see that the value of the second term did not change. So it's 2i and 2i. In short, your k is actually equal to 2. In short, your horizontal line segment passes through y equals 2. Okay. At the same time, this first terms would tell us our a and b values needed for the integration here. Your a is actually for your z sub 1, a is 1, and your b is for your z sub 2, which is 4. Okay? Of course, our t is still unknown. That's the purpose of parameterization. We would come up with a function in terms of a real number t. So with all this already considered, we can now say that our z of t, okay, our z of t identified as t plus ik is equal to t plus your I and then your k, which is 2. So basically, you can rewrite this as t plus 2k, arranging it in specific order. Okay? So, sorry, 2, not 2k, 2i. Sorry for that. 2i, because it's ik and your k is 2. Now, aside from that, we also need its first derivative, right, with respect to t, needed for this formula here. So with respect to t, all the other terms without t will be treated as constant. The derivative of the first term, t, is 1. The derivative of the second term without t is 0 because it's treated as constant. In short, your z prime of t is just equal to 1. Okay. Now, this is now good, and our z of t is already good, but take note, this is not what we're going to use here. It depends on our function. Our function is identified as, okay, f of z is e to the power, is equal to e to the power of z. So if we're going to take the parameterization f of z of t, it's actually e to the power of your z, which is supposedly z. It becomes z of t. Okay, this one here. It becomes z of t itself. So what is z of t? Z of t is actually t plus 2i as indicated here. So our given function is identified as e to the power of t plus 2i. Now, I will suggest another additional step here before plotting that on our given formula. Because if we're going to talk about exponents where the exponents are added, you can break that into product of the same basis, e to the power of 2i. We're doing this because later on, as we move into the integral of f of z dz along the path c, in this case horizontal line segment, which is equivalent to this one here, f of z of t times the z prime of t dt, of course from a to b. This would now be treated as a constant because it doesn't have any t variable. and the integral is with respect to t. And we can use there the constant multiple. We can bring that out later. Let's do it step by step. Okay, so you have here the integral of your f of z of t. Instead of this, let me write the final form. Again, hopefully you were able to understand why from the e to the power of t plus 2i became e to the power of t plus e to the power of 2i. It's actually the reverse form of the addition of, multiplication property of our law of a multiplication of exponents, where if we have the same base, you add exponents. So if the exponents are added, you can break them into two different exponentiations of the same base. So we have here e to the power of t times e to the power of 2i. Take note that the first derivative is actually identified here as 1 dt. And then your a is actually, again, this one here, a is 1 to 4. So those are all very important, 1 to 4. Before we can integrate that, as mentioned, this is a constant. It doesn't have any t variable. So you can move that out according to the property of integrals. E to the power of 2i times the integral of e to the power of t dt from 1 to 4. And we're going to look at this. It's very simple to look at. Take note that if we're going to have the integral of e to the power of t, it's just itself, right? This is equivalent to e to the power of 2i times e to the power of t itself. The derivative of e to the power of, in this case, t, is just e to the power of t itself. But of course, we have here the regions 1 to 4. So just simply need to substitute that in your t. This is still e to the power of 2i times e to the power of 4 minus e to the power of 2i times e to the power of 1. Right? Now, we would like this to be simplified, right? You can actually break it into this portion. Your e to the power of 4 could be e to the power of 1 times e to the power of cube, right? Minus e to the power of 2i times e to the power of 1. I'm doing this because these two are factors. So I could have here e to the power of 2i times e times e cubed minus 1, as indicated here. As we factor this, I still have 1 here term. So basically, the final answer, one of the forms that you can try, is actually e to the power of, when we add exponents here, can I do this? 1 plus 2i. I don't know if it's okay with you. 1, of course, add exponents, just simply rearranging them in how we write complex numbers, times e to the power of cube minus 1. I believe this is okay at this point. This is actually the answer, or the integral of the given function e to the power of z along the horizontal line segment from 1 plus 2i to 4 plus 2i, using the parameterization of horizontal line segment and all of these necessary operations together with some factoring process to simplify the final answer. Thank you very much for watching.